there! Welcome to Mathematics Alive Algebra Lesson 29, Solving Systems of Linear Equations in Two Variables. Definition 1. System of linear equations. Two or more linear equations using the same variables form a system of linear equations. They are also called simultaneous equations. Definition 2. Solution set of a system of equations. This is the set of all ordered pairs of real numbers x, y that will satisfy both equations in the system. Definition 3. Consistent system. A system for which there is only one ordered pair as a solution. The graphs of the two equations intersect at one point, which is the graphical solution, as illustrated here. Definition 4. Dependent system. A system which has an infinite number of solutions. The graphs of the two equations coincide to form a single line. The solution set to a dependent system is a line of solution representing any of the two equations. So, we express the solution set as the set of all ordered pairs x, y such that then you give the equation. We usually give the simpler of the two equations. And this is an example of a system which is a dependent system. There is only one graph because the two equations have the same values for the table of values here. Definition 5. Inconsistent system. A system which has no solution. The graphs of the two equations form a pair of parallel lines. The solution set to the system is empty. So this is an example of an inconsistent system. There are two methods of solving systems of linear equations. They are algebraic method and graphical method. So for the algebraic method, we solve by methods of elimination or by substitution. And for the graphical method, we graph the two equations to determine the point of intersection of the two lines. The point of intersection is the solution to the system. Steps in solving a system of linear equations by elimination. Number 1. To eliminate a variable, their coefficients must be additive inverses of each other. If not, get the LCM of the coefficients of the variable you want to eliminate. Then, change the equation to their equivalent equations where the coefficient of the variable to be eliminated are additive inverses of their LCM. So, for example, we have these two equations and we want to eliminate x. So, the signs of x must be one positive and one negative. So, what we do is multiply equation 2 by negative 1 so that the sign of x are additive inverses of one another, and when you add these two, it will become 0 or it is automatically eliminated. So number 3, you add the two equations and solve for the remaining variable. So here we add this is 0, then we add this 2, we have negative 3y, then we add this, we have a 0, therefore y is equal to 0. And then we substitute this value to any of the two equations and solve for x. And therefore, the solution set to the system is 2, 0. Solve the system of linear equations both algebraically and graphically. Number 1. Equation 1, x plus y is equal to 5. Equation 2, x minus y is equal to 3. We eliminate y by simple addition because they are already additive inverses of one another. So we add x plus x equals 2x, and then 5 plus 3 is equal to 8. Dividing both sides by 2, we have x is equal to 4. And substitute 4 in equation 2, we have 4 minus y is equal to 3. Then solve for y, we have y is equal to 1. And the solution set is the ordered pair for 1. Then here is the graphical solution. We find the x-intercept at y equals 0 for equation 1. So x is equal to 5, and then we find the y-intercept at x equals 0, y is equal to 5. And then we put these values on a table and then graph equation 1 here. We have the y-intercept 0, 5, and the x-intercept 5, 0. So this is the graph. And then we find the x-intercept at y equals 0 for equation 2, x equals 3, and the y-intercept at x equals 0, y is equal to negative 3. Then we locate these points, y-intercept 0, negative 3, x-intercept 3, 0, and then we find that the two graphs intersect at the point 4, 1, and this is the solution to the system of linear equations in two unknowns. So the solution set is the ordered pair for 1. Number 2, we have equation 1 and equation 2. Then we solve it graphically. We have equation 1. The x-intercept is at y equals 0, x equals 2. The y-intercept is at x equals 0, y equals negative 3. And it is given in the table. Then for equation 2, the x-intercept is y equals 0, x equals 2, and y-intercept x equals 0, y equals 6. It is given in the table, and the two graphs intersect at 2, 0. So the solution set is equal to the ordered pair 2, 0. Number 3, equation 1 and equation 2 has the following x-intercept and y-intercept. We'll just look at the table here. So for equation 1, we have 4, 0 and 0, negative 4. And for equation 2, we also have 4, 0 and 0, negative 4. So they have the same x and y intercepts, so they have only one line, and their solution is a line of solution. So the solution set is expressed here as all the ordered pairs xy, or all the points xy, such that x minus y is equal to 4. This equation is the equation for equation 1. Algebraic solution for number 3, and we will solve this by elimination method. We multiply equation 1 by negative 3 to eliminate x, and then after multiplying by negative 3, we have 0 for x, but we also have eliminated y. So the result is 0 equals 0. This indicates that the two equations are equivalent, so they have the same graphs. And the solution set is a line of solution represented by all the ordered pairs x, y such that x minus y is equal to 4. Number 4, this is the graphical solution. We have equation 1 and equation 2. The intercepts are given here, x-intercept and y-intercepts for equation 1 and equation 2. And as we see in the graph of equation 1 and equation 2, there is no intersection. There is no point of intersection, so the solution set is empty since the two lines are parallel. And solving number 4 by elimination method, we have eliminate y by multiplying equation 1 by -2, and we end up with 0 is not equal to 6. So this is an inconsistent system, and therefore the solution set is empty and there is no solution. The graphs of the two equations are parallel lines. Now, let's go to method of substitution. This is another algebraic method of solving a system of linear equations into unknowns. Step 1. Solve one of the given equations for one variable in terms of the other. Example, we solve for y in terms of x, or we solve for x in terms of y. Let's look at this example. So in equation 1, we solve for y in terms of x. So y is equal to 5 minus x. And then we substitute this value to the value of y in equation 2. And then we solve for x, and we find that x is equal to 4. Now we have one value, so we can substitute this to the value of y in equation 1. Number 3, substitute the value of the variable obtained in step 2 to equation 1 or equation 2 to solve for the remaining variable. So we substitute x equals 4 to equation 2, and we get y is equal to 1. So the solution set is the ordered pair for 1. Example number 2, we have two equations here, and by method of substitution, we rewrite equation 2 as y is equal to 6 minus 3x, and we substitute equation 3 in equation 1, this value for the value of y in equation 1. So simplifying this expression, we solve for x and we end up with x is equal to 2. Substitute x is equal to 2 in equation 1 or equation 2. So equation 2 is equal to 3 times 2 plus y is equal to 6, and then we solve for y, and y is equal to 0. So the solution set is the ordered pair 2, 0. I hope you have learned some valuable techniques in solving simultaneous linear equations in this video. In my next video, I will discuss quadratic equations into unknowns and graphing parabolas. Follow my next video, and please like, share, and subscribe to this channel by clicking the button below. Thanks for viewing, and bye-bye!